Mysteries of Matter show. Guess what? It's question and answer week, which means you get to ask us the questions.
That's right. Today we have our special Mysteries of Matter Revealed episode.
So what are you waiting for? Send us your questions now.
Enjoy the show!
In this show, we perform a lot of experiments.
And safety is very important to us, so we need to warn you to always be safe when performing labs. Here are some examples of lab safety equipment that you should always use.
Some important pieces of lab equipment are goggles, gloves, and a lab coat or apron. You need these to keep the substances off of you when performing experiments.
And you should always use proper equipment to stay safe. You won't want to pour acid into a paper cup, for example.
So make sure to always use these items when performing experiments. Hey Amelia, it looks like we got our first question.
Cool!
It says, Amelia and Emily, what is an atom and what is it made of? How is an atom different from a molecule? Jenny K.
Let's go see if we can answer her question.
In this experiment, you'll see an example of how atoms come together to form molecules.
We're going to attract paper clips to a larger magnet to show you in a general aspect how molecules are formed. The paper clips will represent the atoms.
A molecule is a neutral particle which is made of two or more atoms.
Atoms join together by sharing their electrons. An atom is the most basic particle from which all matter is formed.
So what you just saw is not what an actual molecule looks like. You simply saw paper clips being drawn to a magnet. Magnetism is similar to how atoms join and share electrons, which makes for a good example of how molecules form.
That's right. When atoms come together to form molecules, they share their electrons through covalent bonds or exchange them through ionic bonds. Here's an example of an atom and a molecule. This is an example of an atom, up close, since in reality they're microscopic. This is its one proton, its one electron, and this is its nucleus.
This is a water molecule. It has one oxygen atom and two hydrogen atoms. Together the atoms make a water molecule.
So now you know all about atoms and molecules. Emily, let's see if we got any questions by mail today.
Okay.
Looks like we did get something. It says, Dear Emily and Amelia, I'm learning about pure substances and mixtures in science class, but I can't grasp the difference. Can you please explain it to me? Marissa M.
Well, Marissa, I think we can help you with your problem.
Here we have two pure substances, baking soda and hydrogen peroxide. But before we move on, you should know what a pure substance is.
A pure substance is basically a single kind of matter. The two types of pure substance are elements and compounds. Our two substances are compounds. Now that you know what a pure substance is, you're probably wondering what the difference is between that and a mixture.
Instead of just telling you, we decided to show you.
To create a mixture, you need to combine two or more pure substances. So watch what happens when we mix the baking soda and hydrogen peroxide.
When we combine these two pure substances, we created a homogeneous mixture. A mixture is specifically two or more substances that have been mixed together but not chemically combined. Homogeneous means that our substances were evenly distributed.
This experiment was basically a way to help demonstrate the difference between pure substances and mixtures. Mixtures are made of pure substances, and pure substances have only one kind of atom or molecule.
Hopefully this helped you better understand pure substances and mixtures. Hello, this is Mysteries of Matter. How can we help you?
Hey, it's Melissa, and I was wondering if I could ask you guys a question.
Go right ahead.
Well, I have a project due next week about particle movement in the states of matter, but I have no clue. Please help.
Don't worry, I think we have the perfect answer for you.
Thanks.
Bye.
Bye. To help you with particle movement, we have an example of a solid, a liquid, a gas, and a plasma. But first, let's look at our chart.
As you can see, the particles in solids are fairly tightly packed together and can only move when vibrating. In liquids, the particles are fairly spaced apart, but still close together. They can slide past each other. Gases, the particles are very spaced apart. Plasmas are ionized gases and are a little more difficult, so we'll explain that later.
First up, we have our solids. The particles in solids, as you saw on the chart, are very tightly packed together, and so they can only vibrate slightly. So solids have a definite shape and a definite volume.
Next up are liquids. As you saw on the chart, liquids can slide past each other and move because they are fairly spaced apart but still close together. This makes it have an indefinite shape and a definite volume.
Before we move on to plasmas, let's talk about gases. The particles in gases are very spaced out and can move freely. So therefore, gases have an indefinite shape and an indefinite volume.
Next up are plasmas. Before we explain plasmas, some examples are the northern lights, fluorescent lights, and the sun.
What you just saw was a video of ball lightning, which is a plasma.
Plasmas are ionized gases, meaning that they are similar to gases, but some of the particles are ionized. Like gases, plasmas have an indefinite shape and an indefinite volume.
Because plasmas are ionized, they are very good conductors of electricity and are easily affected by magnetic fields.
We hope this helped you understand all the states of matter, and hopefully plasmas make a little more sense now. Emily, looks like we got a new email.
Oh cool, what does it say?
It says, Emily and Amelia, I'm a huge fan of your show, and question and answer week came just in time. I'm learning about the periodic table of elements in class, but I'm so confused. What is the periodic table of elements? What are the elements? How many are there, and what are their properties? As you can see, I'm very confused and need your help. Your loving and confused fan, Sandy S.
We'll send a reply.
Okay, Sandy S. We understand your confusion and would love to help you out. Just keep on watching the show. Emily and Amelia.
So to start off, the periodic table is just a way to organize all of the elements, as you can see here.
All of the elements are pure substances, which means that they cannot be broken down by chemical or physical means.
There are over 100 elements in the world today, and scientists are still trying to find more, and they all appear on the periodic table of elements.
To help you with the elements, we have some examples.
For instance, aluminum is in aluminum foil and soda cans. The atomic number of aluminum is 13, which means that it has 13 protons in its nucleus.
Another element is zinc, which can be found in some sunscreens. Zinc is in group 12, period 4. Groups and periods are a way to organize the periodic table of elements. Also, zinc's atomic mass is 65.39. This tells you how much mass one zinc atom takes up, and it can also help you know how many protons and neutrons are in one atom.
There is so much to know about the periodic table and all of the elements, and we have barely gone into it, but hopefully we have helped answer some of your questions.
I need your help. I have a test tomorrow on the law of conservation of mass, and I know next to nothing about it.
We can show you what it means. Just give us a few minutes.
Okay.
Alright, here we're going to show you how the law of conservation of mass works.
First of all, the law of conservation of mass is the principle that the total amount of matter is neither created nor destroyed during any chemical or physical change.
We're going to demonstrate this using an experiment.
To begin, we each have our substances. Amelia is going to perform a chemical change and I am going to perform a physical change.
But first, we must measure the substances. My slice of bread is 29 grams.
And my slice of bread is 31 grams.
Now we will perform our experiments. So now we measure again. My piece of bread is still 29 grams.
And my piece of bread is still 31 grams.
So now you see that a substance does not change when it undergoes a change. A Hey Emily, let's go see if we got any questions in the box today.
Okay. Looks like we did. It says, Mysteries of Matter. In science class, we are learning about chemical and physical properties. We have a test coming up next week, and I am very confused on this topic. What is the difference between chemical and physical properties? Please clear this up for me. Thank you. Lauren T.
Lauren, here's the answer to your question. A physical property is a property that can be observed without changing the substance, like color or state, for example.
And a chemical property is a property that can only be observed when it is changing state. An example of this is flammability, like methane can catch fire and burn.
What we have here is a mystery substance. You can use your 5 senses to try and guess what it is.
It has an orange color. It is obviously a liquid, and it has an orange and citrus scent.
Can you guess what it is? It's pineapple orange juice. You just used the physical properties of a substance to identify it. Now we're on to the part of your question about chemical properties.
A chemical property can only be observed when it is going through a change.
The chemical property you will see here is reactivity. We're showing you how iron reacts when it comes in contact with oxygen for long periods of time.
This piece of iron has not been exposed as long as this piece.
When iron interacts with oxygen, it reacts to form a substance known as iron oxide, but it's more commonly referred to as rust. Now you can see that iron holds the property of reactivity, which says that it can react.
Keep in mind that it is iron's ability to rust that is the chemical property, not the actual rusting.
Hello?
Hi, this is Kyle. Is this the Mysteries of Matter?
Yes, did you have a question for us?
Yes, in my science class we are learning about chemical and physical changes. What is the difference? Aren't all changes the same? What are some examples of these changes?
I think we can help you with that.
Just keep watching.
Thanks.
Bye.
Bye. Here we will demonstrate a physical change.
A physical change is just a change in the appearance of a substance, not the chemical makeup.
We have 2 glasses here. Now watch what happens when we apply a physical change.
Safety first.
Okay.
Okay, now the glass is broken, but it's still glass. Its chemical makeup has not changed at all.
We hope that helped.
Now we will demonstrate a chemical change.
We are going to put this piece of paper into the fire.
Okay, now all we have left are ashes.
The paper changed to form a new substance during its chemical change.
A chemical change changes the chemical makeup of a substance. It is nearly impossible to reverse.
That is why this was a chemical change. And that's the end of our show.
We hope this helped you learn a lot about matter.
And thanks so much for watching.
Bye.
Bye.